So this is what a user see the first time that open ASAP. So there is basically no project, everything is white. I'm not going to go through all the features that I mentioned in the presentation. I would like to just show you how easy it is to run a simple calculation. So in this case, let me choose a molecule. So for example, water. I already have it in my database, so I don't even have to import it or create it from scratch. I just select it from the list of molecules and I press OK. And I already have my project. In principle, I can go here, press and run. And the calculation is already running. I don't know if you are familiar with this kind of code, like Cesta needs pseudo potentials, sometimes basis set, and a lot of input parameters that needs to be set up. And as you see, I didn't do any of this because ASAP already provide some default parameters to allow the user to forget about many things. Okay, this was an example of, as I said, of a calculation in which I just press run without thinking about anything else. But let me just go into more the detail of what can be done if you want to tune a bit the calculation. So here, as I mentioned before, there is the list of projects. I select the single point calculation, which is the most basic calculation, if you want. Then you have parameters. This widget is different for each type of project. So for single point calculation, you have the possibility of manually choosing, changing the position of the atom, initializing some magnetic moment. This is very important if the molecule is magnetic, and choose the properties that you want to calculate. Band structure is not available. Obviously, this is a molecule, it's not a bulk. And let me choose, for example, DOS, PDOS, and charge for this example. So when I press OK, now you have a warning because I already ran a calculation. So it's basically telling me that if I press OK, the previous results will be deleted because I changed some input parameter. The next step is the calculator. I can choose the type, the calculator one from here. As you can see, in this version, we already have Siesta 5. Anyway, I will leave Siesta 4.1 for this example. And as you can see here, the main Siesta or Quantum Espresso or Transista input parameters are divided in different categories to make it simpler for the user. So you have physics, convergency, basis set and pseudo potential, SCF. There is always the possibility for the user to enter in the directly in the text file of the input file and change anything. But if this is many things can be done directly from the interface, which is very good because this you don't have the problem that you might be aware of, for example, typo or conflicting variables. This is not possible in ASAP because it's controlled by this GUI. So, okay, let me run again, then this calculation. And in this case, I'm doing the same thing I did before. I just added this PDOS and charge as analysis. And okay, the calculation already finished. I see here that it's finished because I see it's completed. The status is also here. And now if I go in exit and analyze, I can see the general information. So total energy, HOMO-LUMO, eigenvalues, gap energy. And in this case, I can also see DOS, so density of states for my molecule, PDOS, which is projected density of states. So, for example, I can decide that I want to see the contribution to the density of states only of the hydrogen atoms. And the charge. So there are three methods, Mulliken, Hirschfeld, and Voronoi. Yeah, depending on the purpose of your calculations, results can also be exported in CSV and text file.